I gave one problem, and I asked you to do that. So have you attempted, all of you? The summation problem which came in JEE 99, I told you, right? Summation K from 0 to M, 2n minus K, Ck. Whole divided by, right? This was the problem. Whole divided by 2n minus kcn, all right, and 2n minus 2k plus. Okay. So as you can observe, your summation should come in terms of m and n. In terms of m and n. So were you able to get it? How will you do this? Tell me. कैसे करेंगे?
Sir, there was also another term 2 power n minus 2k.
Ah, right. Okay. One more term is there. 2 power n minus 2. Correct, beta. So now tell me. So as you can observe, I think we should go in the direction of making this into a telescopic sum, that is as a method of difference. So how will you express this? Tell me. How will you express this? Yes. So by converting into factorials, correct? So 2n minus 4k plus 1, how do you want to express that? So can I do one thing? Like 2n minus 4k plus 1, I want to write as 2n minus 2k plus 1 plus 2k. That 2n minus 2k minus 2k. It was minus 4, right? So minus 2k. Can I write it like this? 2n minus 4k plus, correct? Now, let us first simplify the two terms. So what is 2n minus k? So this is this factorial divided by k factorial. Keep on checking the calculations. 2n minus 2k. What will come in the denominator, beta? Denominator? Tell me. 2n minus k factorial, which is going to be cancelled. What else? N factorial and n minus k. Is that clear?
Yes, sir.
And first term, and in addition to this, there is 2 power n minus 2. So first of all, let me keep it like this only. And minus, what do you want to express? Summation, or summation we can put together, minus the whole expression factorial n. Same thing I'm going to write, because the only difference is 2k is there. N minus k factorial 2 power this, along with there is 2k term, I suppose, and whole divided by, in the denominator what is there? K factorial multiplied by 2n minus 2k. So now can you tell me what is the simplified form that we are looking? This is equal to. So this we want to express as, tell me, how can we express this? 2n minus 2k, because n factorial is looking in the numerator, n minus k. So what do you want to do for this? Tell me. K factorial is there. How will you write this? 2n minus 2k factorial. Yes. This whole, how will you express this whole? Tell me better. 2n minus 2k n and n minus k. The denominator I can write as, tell me, 2n minus 2k. What else? Yes. 2n minus 2k ck, something like that. Can you check this? 2n minus 2k, that plus 1 was there, na? So this will be, I think 2n minus 2k I have written incorrectly, na? This should be 2n minus k only. No, it was all right. Okay, 2n minus 2k is all right. And there I have written n minus k. Okay, so this will be 2n minus 2k and what else? N minus 2k it should be, na? So if this is, let us say, v of n, so how will we observe this? Minus. So this is going to be n factorial, n minus k factorial. Okay, let me cancel k in the numerator and the denominator k factorial. Please keep on checking. Hai? Instead of simplifying, let me put it in this manner only. And k factorial will get cancelled. So I will write this as k minus 1 factorial and 2n minus 2k plus 1 factorial. Is that clear? Yes. And this is n factorial, n minus k factorial, 2 power n minus 2k, all upon k factorial and 2n minus 2k factorial. Tell me, is it clear or not? Now,
Yes,
what is this? Now, what is this form? Now, what is this form? In terms of k, basically we want to express. So if you want to express in terms of k, what do you require? In place of k, what do you require actually? You require
k minus
k
1.
If I replace k by k minus 1, that I have to check whether this is equal to this or not. So let us check this. So if this I say is v of k, or let me put it simply as let us say some function of k, ak, let me call this ak. So we are exploring whether we can write this as a of k minus 1. So for that purpose, let me first check ak minus 1. So this is going to be n factorial, n minus k plus 1 factorial, replacing k by k minus 1. This will be 2k plus 2 plus 2, let me write plus 1 into 2. And in the denominator, this is going to be k minus 1 factorial. N factorial anyway I can take out. And this will be 2n minus, tell me, 2k
Plus 1.
plus 2 basically. So plus 2 I'm splitting like that. 2n minus 2k plus 2 into 2n minus 2k plus 1. So basically there is a slight trick here because it is not that straightforward. So we can now multiply. See what you can do. Can you see? You can take 2 common from this in the denominator, this factor. Can you see this factor? If you take 2 common, this 2 will get cancelled. So what will remain here? N minus k plus 1. And if you cancel with this factorial, so can you tell me what term will remain? If you cancel,
n minus k factorial.
Yes, so I'm cancelling this 2 and this whole, and with this also, and I'm writing n minus k factorial. So can you see exactly this thing is written to the right side? This. Correct? So what were we trying to ascertain? Whether this is ak minus 1 or not? See, there are 2 ways to check this. One way is to try converting this into this. So though that is possible, but sometimes it might be time consuming. Another way is you first let that as ak and write ak minus 1 and then try to reform ak minus 1 into this. So sometimes that will work faster. So can you able to see that this is ak minus 1 or not? So telescopic is working or not? It's working. Agree? All of you?
yes, sir.
So what is going to be the final answer? So k from 0 to m. So am will remain in the last और सबसे शुरू में what will remain? अच्छा, for k equal to 0 I cannot put a minus 1. Then what will you do? Then what will you do? In fact, you should start putting the values of k from 1 only. And for k equal to 0, you can solve it separately. Getting the point? You should start from k equal to 1 to m, get the sum. And then a of 0, you write it separately. Because here I cannot substitute k equal to 0. No? So that's it. So am minus a1 and plus a naught. This is your answer. So let us first write the answer. What is a naught? This whole term we have generated this term in terms of k. So what is a naught? Put k equal to 0. So what is this value equal to? Tell me first. A naught. So this will be 2n C0, that is 1. In the numerator, it will be 2n plus 1 2 power n whole divided by denominator k is 0. So 2n cn. Yes, and 2n plus 1 will get cancelled. So a naught is 2 power n upon 2n cn. Let me rub this. So I simply write a naught as 2 power n. Right? And minus a1, I want to write first before am. A1 is going to be how much? That you can start putting from here. So if you put k equal to 1, you getting the point? So k equal to 1. So all other terms are going to be cancelled. So what is a1? That is going to remain. So correspondingly, if you put value here as 1, so what is that value? What is that value? So n factorial into n factorial.
Shouldn't we put? Okay, no.
Pardon me?
Yes, sir, no. Yes.
You got the point, no? So basically, why am I evaluating a naught? Because here I do not want to substitute k equal to 0. No? So no problem. Or else what you can do, you can substitute over here. I think that will be better rather than here. So you can simply substitute here. Yeah, that will be better. Instead of calculating a naught only, no? What I should have done. At this place you can do. Because anyway, they are same terms, no? This is a simplification. So a of m, so I'm writing the final answer. So a of m is going to be n factorial n minus m factorial 2 power n minus 2m whole divided by, in place of k, I'm writing m beta. 2n minus 2m factorial. This minus, then put k equal to 0. So this is going to be n factorial 2 power n. Achha, if you put k equal to 0, so this term is itself 0. Can you check? If k is 0, this term is 0 itself. So this is the final answer. Simply a. This is your final answer. So all of you have understood, right? Directly based on the telescopics. Is it clear to all?
Yes, sir.
I'm going to give you another problem of the same year. So basically, u and v are unit vectors. W is any vector in space. To satisfy this equation, you have to obtain the maximum value of this box product, u cap, v cap, and w dot. Okay. Yes. So tell me, what is the maximum value? Are you able to do this?
1, sir.
No, 1 is not the maximum value.
Mod omega square.
No, answer is a numerical value. Like 1 by 2, 1 by 3, 1, 2, like that.
1 by 2, sir.
1 by 2 is the maximum. So how will you do this? Tell me. We can do many things with this vector equation. Na? So STP anyway we can obtain. So tell me, what are the steps involved? So first of all, we will prefer taking dot with each and everything. So let me take TD stands for taking dot with u cap first. So this will be u dot w equal to u dot v, right? Next, take dot with v cap. So v cap dot w cap plus VWU box, and that box I want to let as X. So this plus X equal to 1. And then take dot with W cap also. Sorry, W vector also. So this will be W square equal to V dot, there it is only W, not W cap, V dot W. Okay. So that is your W square. What else we can do? What else we can do? We can do many things. We can square this also. So if you square this, what will you get? W square plus W cross U square by Lagrange's identity. This is how much? W square minus W dot U square. Everybody remember A cross B mod whole square is equal to how much? A square B square minus A dot B whole square. And plus 2 this dot this. A plus B mod whole square, I am opening the formula. So A square plus this whole square plus 2 this dot this, which is 0. So you are following this, right? Everyone? And right hand side is 1. Is it clear? Till here? Yes? Tell me.
Yes, sir.
Okay. So now you can simplify this. First equation, let me take as K. And then I can substitute the third equation. In fact, the last equation. 2W square equal to this, I can write 1 plus K square. And this is K. W dot U cap is K. So what is the value of X from the second equation? So X is 1 minus V dot W. And see here, V dot W is W square. So 1 minus W square. And W square you can substitute from the last equation. So 1 minus 1 plus K square by 2. So this is X equal to 1 minus K square by 2. So what is the maximum value of X? So this is going to be half when K is 0. K is 0, that means when U and V are mutually perpendicular. Is that clear? You can do this. Please check. When U and V are mutually perpendicular. So in that case, and can you obtain in that case W? Can you obtain? Yes. Or in other words, can I obtain W in terms of U and V? Suppose this is the problem which JEE asked in 1999. What else? In one or more than questions, I can frame similar type of other questions also. So can you tell me W plus W cross U is V cap? Yes, you will be able to obtain W in terms of U and V. Can we do that? So tell me, how will you obtain W in terms of U and V now? Yes. Can you tell me? What should we do? For that, we should take, please tell me, W
Cross
vector.
product with V.
Yes. Tell me, cross with
V.
I think cross with U will be preferred better, because W cross U you can write in terms of W, not W cross V. Getting the point? So TPO and then U cap. So what is the full form? TPO and then C and then C and then U cap. Tell me, like TD, I have told you the full form, taking dot with this. What is this? What is this? In cross, what matters? Tell me, order matters. So this is taking post cross with U cap. समझ में आया? Taking post cross with U cap. So I think you will be able to understand W cross U. Understood, right? Because here, what matters? Order matters. Tell me, is it clear?
Yes, sir.
So we are discussing that question where if W is asked, then we can also calculate this. Now W cross U cap I can replace from the first equation as V cap minus W. Getting the point? V cap minus W. So this could have been the another way. Plus, here you know what is the formula. Vector triple product. U cap minus W vector equal to V cross U. And what is U dot W? U dot W, see, we have already obtained in the first dot product. See here, U dot W is same as U dot V. Correct? So now you have obtained vector W exclusively in terms of U and V. And what is that value? What is that value? That is U dot V times U cap. What else? Plus V cap plus U cross V whole divided by. This you could have also done by starting with fundamental theorem in space, which says that any vector can be expressed in terms of three non-coplanar vectors. And what are they? U, V and U cross V. Is that clear? So without loss of generality, I can start with U and V as non-collinear vectors. Then this triad U cap, V cap and U cross V will be a set of non-coplanar vectors. And collinear case you can take separately if you want to do this in another manner and arrive at this result. Is it clear? Tell me first.
Yes, sir.
And from here also, you can get the same question. See, U, V, W cap max, W vector max. What is the full form of this? Tell me U cross V dot W. So basically what will I do? So let me keep this separate, this method separate, so that you don't confuse with this. So in the first approach, what we have done, we have purely applied the scalar relations, only dot product we are able to get the value. But when you obtain vector product, then you have obtained W in terms of this. Now you can take TD U cross V. समझ में आया? इसका मतलब taking dot with U cross V. So this will be U cross V dot W. इसको X मान. The first two terms will vanish, taking U cross with this. And with this, what will come? Lagrange's identity. So U square, V square, they are of unit magnitude. So you will get simply the result. So in whatever way you can do, you will be able to get this same result. So I think this is clear to all. Yes, tell me.
Yes.
Clear now? Okay. So I will give you another problem. Write this.
Sir, f dash should be thrice differentiable function.
Pardon me?
F dash x should be thrice differentiable function if that second one should to be applicable.
Yes, but already they have given no, G is twice differentiable. So obviously F will automatically be, because G is another name of F dash. No?
Okay.
Getting the point? This they have given because they just want to confirm that this is making sense. G equal to F dash. So for that they are saying that F dash exists. And G they have given, G is another name of F dash, no, nothing else. Basically this problem involves only one variable F. Okay. Okay, you try this. Yes, so you are trying this. So tell me, how will you start? What all quantities are given and what is to be checked? So G of C, basically there is only one variable involved, F. G is F dash. So what is that we want to prove? So to prove G of C is nothing but F dash C. Tell me, into F triple dash C is negative. That means there exists some C where sign of F dash and F triple dash are opposite. That is what we wish to prove in this problem. Is it clear? Question is clear? Yes? Tell me,
Yes.
all of you. Okay. Now what is given in the problem? That magnitude of fx is smaller than 1. And there is one more information, f is square 0. The way this information is given, so this is a hint that you should let a function hx as what? Tell me, hx equal to
F square x plus G square x.
g square x, correct? And g is nothing but f dash. So I am omitting x just for the sake of simplicity. I am writing this as f square plus f dash. So is it understood, right? At x. It is understood in terms of x. So what is the information? H of 0 is 9. Getting the point? H of 0 is 9. And what else do we know about these values? G of 0, we have some information. Because f of x is less than equal to 1, that means g square 0 is what? Greater than equal to 8. Right? Correct? That means g of 0 magnitude is greater than
And less
2.
than 9.
And yes,
Less than
obviously
9.
less than 9. Yes, correct. So it will lie between 2 root 2 to 3. So this is the information with respect to G. Basically, G is nothing but F dash 0. So F dash 0 lies between 2 root 2 to 3. So this is the information that we have right now. Since F dash is involved over here, which is nothing but G. So can I apply LMVT? There is a hint of LMVT also, because unless until you have some information of F dash, you cannot proceed any further. So in which domain you want to apply LMVT? Tell me. So by LMVT, I can apply because it is a differentiable function. Correct? For F. In which interval? On, let us say, 0 to 3 I can apply. Or similarly, I can apply for -3 to 0 also. So there exists some, that number I can say, that number is D. So F dash D equal to F3 minus F0. This whole upon, tell me, 3. And the function magnitude is less than 1. So difference of these two will be at most 2. Can you check this? So magnitude of F dash D must be smaller than 2 by 3. Is it clear or not?
Yes.
That means what is F dash D? G of D only. So G of D is less than equal to 2 by 3. That is your F dash. Correct? Now what will happen to F? What will happen to F? Tell me. If I am concerned with F, its derivative is G. So at 0, its value is anywhere between 2 root 2 to 3. But at D, basically G of D is nothing but, let me put mod here. This is F dash D only. This is F dash D. So now you tell me, what will be the graph of F? How will it look like? How will it look like? Or for that matter, if I want to plot H. So I want to plot H now. So H of 0 is 9. On top, H of 0 is 9. Now look carefully. This value is 9. Can I say there must exist some maxima? Can I say that? Because h of d is how much? Can you tell me what is going to be h of d? The same d which you have obtained here. H of d will be how much? So it will be f square d plus f dash square d. F square d is anyhow less than 1 and f dash square is less than 4 by 9. So can I say that h of d will always be less than or equal to 1 plus 4 by 9? That is 13 by 9. Do all of you agree with this?
Yes.
देखो है ना, I have substituted d here. तो f square किससे कम है? यहाँ से देखिए f square is smaller than 1 and f dash d square, see here, less than 4 by 9. That means if you want to plot the graph of h, so you are at 9 at x equal to 0. That means you have to come down on the right side. Achha, similarly on the left side also you have to come down. Can you tell me why? Can you tell me why?
By LMBT again we can between -3 to 0.
Yes. Yes. So I can again apply LMVT. In which interval?
-3
3 to 0.
Yes. For f in -3 to 0, there might exist some e. So where h of e will also be smaller than, similar arguments I can keep. So look carefully. So at most till 13 by 9 you have to come down. So what is confirmed, maxima or minimum? So you cannot come down without taking a maxima. In the best case, what could be the case? 9 itself could be a maxima. So either it will go up and then it has to come down because value has to reach lesser than 13 by 9 on either side. Therefore, there must exist some point of maxima since it is a differentiable function, h we are talking about. Tell me, till here everything is clear? Tell me.
Yes, sir.
That means there is an alpha, there exists an alpha from -3 to 3, where 100% what is going on? 100% its derivative must vanish because it is a point of maximum. Is that clear? Now, this is your hx. See here, this is hx. See my pointer. Now, what is h dash? What is h dash? Yes, so h dash will be, tell me fast, 2f f dash. Correct? This is your h dash. Can I take 2f dash common? F plus f double dash. This is your h dash. Now listen very carefully. If I put h dash equal to 0, then now there are two possibilities. Because if it is a point of maxima, h dash must be 0 at alpha. So I am just checking. If h dash is 0, then whether f plus f double dash should be 0 or f dash is 0. Suppose I assume f dash is 0. So if f dash is 0, that means if I put here f dash 0, then what is going to be the value of h of that point? It is f square only. And f square is less than 1. That means the maximum value is less than 1, which is not possible. Listen again. If I put f dash equal to 0, then f dash is 0. That means h of that value alpha is f square of alpha. And f square in any case is less than 1. And you can see your maximum value should be either 9 or more than 9. Therefore, at the maxima, f dash can never be 0. Is it clear? Is it clear or not?
Yes, sir.
That means at the point of maxima where h dash alpha is 0, what is happening? F plus f dash must be 0. Must be 0. Correct? Now, this is your h dash. What about h double dash? So if I differentiate this once more, H double dash. What will I get? 2f dash square, 2f f double dash, then 2f double dash square, then 2f dash f triple dash. Correct? Agreed? Now what is common in the second and third term? What is common? Tell me.
F double dash.
Yes. I am deliberately calculating the value of H double dash at alpha. Can you tell me why? Can you tell me why?
Remaining all terms are positive except last term.
No, in fact, I can only evaluate at alpha because I have the information only at alpha. No other.
Positive downwards.
Yes. So H double dash alpha will make sure that these two middle terms will vanish because F plus F double dash is 0. Because F plus F double dash is 0. See? Agreed? Tell me.
Yes, sir.
That means H double dash of alpha will be 2F dash square plus 2F dash F double dash. And from the diagram, since it is a point of maxima, its
The triple
concavity
dash,
is
sir.
down. Pardon
The
me?
triple dash. The
F
triple
triple
dash.
dash. Yes, yes, F triple dash. And from the concavity of this graph, H double dash at any point must be strictly negative. Agreed? Agreed? So to make it negative, first term is always positive. So to make it negative, what is sure 100%? Tell me. That at this alpha, F dash alpha into F triple dash alpha must be of opposite sign. तो देखिए आपने इसमें ये भी बता दिया, you are even able to ascertain the fact that what that point must be. So he is only asking there exists C, and we are confirmed that this C, we can have this information only about that point, which is the point of maxima of H. This could be for sure no other point. This could be any other point in general. But when we are about to say that for sure what is that point, so 100% surety is valid for alpha. So this was again a beautiful problem which was missing from generally previous year questions. This was asked in the year 2005 as a subjective problem. See, the concept should be very clear when you do this. So is it clear to all?
Sir, can you tell the last part again?
Which thing you want to ask? Please tell me.
H double dash of alpha, why is it less than 0?
H double dash, beta, when the concavity of any graph is down, you know, this you should remember. Whenever a graph is like this, then its double derivative is always negative. When the graph is like this, you don't know about the point of maxima. First derivative is 0 and second derivative is negative. And for minima, first derivative is 0 and second derivative is positive. Is it clear?
Yes, sir.
Correct. Okay, so you can write this. You can write this. See, there are many things involved in this question. And ultimately, you are able to get the desired result. Okay. Let me read the problem for you. This is again a previous year JEE problem, which is again missing. Can you guess the year? This came in JEE 2020. Sorry, not 2020, 2000. 23 years back. So let me read the problem for you. Let ABC and PQR be two triangles on the same plane. Let perpendiculars drawn from ABC to the sides QR, RP, PQ respectively are concurrent. Prove that perpendiculars drawn from PQR to the sides BC, CA and AB will also be perpendicular. And you have to try this using vectors. Using vectors, you should try this. Okay. So though this can be attempted through pure geometry also, but then it will be quite tedious job to do it through pure geometry. Using vectors, it can be done in a better, or I should say faster. So try this. Yes, Ved Prakash.
Lines.
Yes, you solving the question.
Yes, sir.
So understood the question. What is asked in the problem? Yes. So what should be the approach? How should we begin? Tell me. Tell me. How shall we start? How will you start? Tell me first.
Sir,
Yes.
in the question you gave PQR are to the sides BCCA AB are must be perpendicular.
No. You have to show that. Yes. If first condition is satisfied, then you have to prove that perpendiculars from PQR to this will be perpendicular. That is what you have to prove.
But they are already perpendicular, right?
They are already perpendicular. How? That means that was a yes. You have not understood the question. So first I will try to make you understand the question. Okay. PQR. So perpendicular from A to QR. Can you see this side QR? You can extend this also if you wish. Then you draw that line from A to QR. Then from B to PR. Extend this PR and then draw perpendicular from B to PR. And then from C to PQ. C to PQ. These
Understood,
three
sir.
are concurrent. This is what it is given in the problem. And what you have to prove? That perpendiculars from PQR to the sides PCCAB, they will be perpendicular. So you want to try for 1 minute? Try this. Then I will tell you.
Perpendiculars from PQR to BCCA will be concurrent. We should prove that, or will be perpendicular. We are drawing
Oh, sorry.
perpendiculars.
Okay, sorry. Last time, yeah, you are right. This will be concurrent. Please make this correction. Last word is not perpendicular because perpendicular I have already. The perpendiculars from this will be concurrent. This is what you have to do. Okay, I think you are having this doubt only, na?
Yes, sir. I have this doubt.
Okay. Actually, I forgot to write concurrent. Same thing. They are concurrent, not perpendicular. Okay, now you try. Yes, so tell me, how will you start this? How will you start? Like, what should be the approach? Like vector equations we have to write? Yes? Tell me, all of you. Tell me the starting step. How will you make use of the fact of the first information that ABC to these sides are perpendicular, are concurrent? So how will you make use of this? Tell me first. Yes, tell me first, beta. Anybody. Just starting step I am asking. You can share. What should be the first step? Please share. Yes.
PQR will lie on the lines BC, AB, and AC.
Why? This need not be the case. These are two triangles. They could be anywhere. No? As I told you, you can extend this. Yeah, they can be extended also. They lie in the same plane, but it is not necessary that ABC must lie over there. What I'm asking, what should be the first step? Using vectors you have to do. So what do you do in vectors? Tell me.
Assign vector notation.
Yes, position vectors. That was what I'm asking. Na? Acha. Without loss of generality, I want to assume origin of vectors. So where do you think I should keep the origin? That will be best.
Concurrent point.
Concurrent point. Very good. So let me mark this point of concurrency as what? As what? Origin of vectors. Correct? And these as ABC and PQR. So once you write this, no, then the problem will become simpler. Now what is given? Since they are concurrent, so AR is perpendicular to, tell me, this should not keep this as R. I should name it something else. Let me name this as K. So K is the origin of vectors. So AK is perpendicular to QR. So what does it convey? That A dot Q minus R or R minus Q is 0. जो first relation है, that is what I am writing over here. Are you following this? B to RP. है ना? So B to RP, all are concurrent. That means KB vector and RP vector, they are perpendicular. So B dot R minus P is 0. Are you following this, everyone? And CK, that is C dot PQ vector, which is P minus Q or Q minus P. This is C. This is the relation which is given. Is it clear? Please tell me fast.
Yes, sir.
And the next thing what you have to do, instead of proving that perpendiculars drawn from PQR to these sides are concurrent, what you can do, you first draw perpendicular from P to BC. From P to BC. Correct? So let me draw this perpendicular for you. Suppose I have drawn this perpendicular from P to BC. Okay. Let me use another color. P to BC like this. And next from Q to CA. So from Q to CA. So I can extend CA. I can extend CA and then draw perpendicular from Q to CA. So this is going to be the perpendicular from Q to CA. So obviously these two lines will intersect somewhere, these perpendicular lines. So this is the point of intersection of first two perpendiculars. I've just drawn this for the reference. So let me first name this point as M and assign the PV as M. Now if I am able to show that, RM is perpendicular to AB, then we are done. See here. If I'm able to show that RM is perpendicular to AB, then they will be concurrent. Is it clear or not? I can extend AB.
Yes.
And if so, that is how you should approach and you should understand the problem. So what I have assumed, the point of intersection of first two perpendiculars, wherever they will intersect, is M. Okay. So this will be what? This will be what? And can you tell me, someone might argue, sir, how they can be parallel also? No, they cannot be parallel. Why? Because they are sides. No two sides are parallel and hence they must intersect. Correct? Is it clear?
Yes, sir.
Yes.
Yes, sir.
So what is given to us? AM dot, tell me. AM, not AM, sorry. PM dot BC is 0. So what is PM? M minus P M minus P dot BC, which is C minus B or B minus C. This is 0. है ना? Second relation, QM dot CA is 0. So what is QM? QM dot CA is 0. So these are the 5 equations which are given to us. And to prove, you have to prove that. What is that we want to prove?
R dot A minus B.
Yes, Rm dot AB is 0. That means we want to show that M minus R, correct, dot A minus B, this should be 0. Now we should try using this. So let us begin. So from here, can you tell me from this, how can I evaluate R dot A minus B? What should I do? See, B dot P is here. So these 2 equations you can add. M minus P, M minus Q. See here, these 2 equations I am adding. So M dot B minus C, M dot C minus A. So that will be M dot B minus A. And P dot B minus C and Q dot C minus A, I am transferring to the other side. So P dot B minus C and plus Q dot C minus A. Now it will become a problem of simple manipulation. Now see here. We want to express this in terms of R. So what is P dot B? P dot B. See here P dot B from this. See my pointer. What is P dot B?
B dot R.
B dot R. So keep on writing B dot R. What is P dot C? P dot
P
C.
dot Q.
P dot Q. From here. P dot C is C dot. Correct. So minus C dot Q. And write this as plus C dot Q minus A dot Q. What is A dot Q?
A dot R.
A dot R. So minus A dot. So these 2 will get cancelled. What will come common? B minus A. R dot B minus A. I shall write this. Now transfer B minus A to the other side or take common. So M minus R dot B minus A or A minus B, and multiply with minus sign. So this is what we wanted to do. Tell me, is it clear to all? So how do you do this type of problems? Is it clear?
Yes, sir.
Sir.
Good. So write this. Write this. Next, I will give you one matrix problem. Let A and B be 2 square matrices of same order n, and they commute. That is AB equal to BA. A power P is identity matrix and B power Q is null matrix for some natural numbers P and D. Check whether A plus B is invertible. If yes, then find its inverse. Otherwise, just ignore.
There is inverse 1.
Inverse. What is the
I-
inverse? That
I, sir.
is the inverse. That means A plus B equal to I you have obtained.
Yeah, IN.
Not I, man. Please check. Please check. Yes, tell me, how did you obtain I?
Just I put some values, sir.
Values for what? Values for what?
Just like I equal to A equal to I, B equal to 0.
For all possible values of P, Q, A, B which satisfy this, you must be able to get its inverse if it is invertible. So first of all, tell me, is it invertible or not? How can I check?
It should not be equal to 0.
Which one? What should not be equal to 0?
Det
Determinant.
of A plus B.
Determinant of A plus B. So how will you check that? That is what I am asking you. See, I will tell you, A power P is I and B power Q is null matrix. So you should make the exponent same so that you can proceed further. So what will be A power PQ? Tell me. This is I only.
sir. I.
And what will be B power PQ?
0.
Correct? Now, acha, let me ask you one more thing. What will be minus B power PQ?
0.
Null matrix. Why am I writing this? Because I want to make A minus B. So, if I want to factorize this, acha, can I factorize this in matrices? When I have the liberty to factorize? When they commute. When they commute, you can expand or apply the operations as in your number systems. That you know or not? Like A plus B whole square, like that. Since A and B commute, AB equal to BA. So A power n minus B power n. Tell me what will be the factor? This you know or not? X power n minus Y power n. Then X minus Y always divides. A minus minus B. So A plus B will be a factor or not? Please tell me.
Yes.
And what will remain? PQ minus 1. All the powers keep on reducing the power of A and keep on increasing the power of minus B. A power PQ minus 3 B square. Last term will be minus B power PQ minus 2. Is it clear? Please check. All are defined? Yes, because A and B are given square matrices of order and P and Q are natural numbers. Is it clear or not? So now what you can observe from here, what you can observe? That ultimately powers of B are increasing. Someone might argue, sir, A power PQ minus 3 might be a negative number if I take P and Q as 1, but since A is already invertible, A is invertible, see, A power P is I, so its determinant is either 1 or minus. Correct? And B, there is no negative power. You can observe because B is non-invertible. Hence, if you see this, if you put determinant on both sides, so what is left hand side? This is I only. This I can put equal to I, A power PQ, and hence the product of two matrices I, then they are inverse of each other. Hence, so both of these are proved that this is invertible. And what is its inverse? This thing in bracket, this whole is its inverse. Is it clear or not?
Yes, sir.
You got the concept now? So you have to try to generate A plus B, and whenever you have to observe whether it is invertible or not, either try to obtain its determinant or try to find some matrix which when multiplied by that will give you I matrix. Is that clear? So this is the inverse and hence it is invertible. Clear?
Yes, sir.
Understood? Okay. So then we will meet in the next class, and all the topics that I'm covering, we will try to cover each and every topic so that there is a quite good number of distribution of problems that we might have discussed before you actually appear for JEE Advanced. Is that clear?
Yes,
So
sir.
now I'm taking your leave.
Yes, sir.
See you in the next class. Take care.